Hi, I'm Ellen Stofan, also known as Dr. E.
And I'm Thomas Zurbuchen, also known as Dr. Z.
And we're here at the Smithsonian's National Air and Space Museum for another episode of EZScience. Thomas, I'm really excited today because we're talking about a new mission that's going to launch soon, and it's studying the universe using a different technique than one that most people are familiar with.
That's right, it's an X-ray telescope, and it's actually an imaging polarimeter, also known as IXPE. It's an Explorer mission. It's much smaller than many of the other missions, and it's looking at X-rays in entirely new ways.
You know, here at the Air and Space Museum, we really try to talk to the public about how the fact that we look at the universe using lots of different kinds of eyes, and by using those different eyes, we can actually learn much more. And what I mean by that is we're looking at different wavelengths, because each of those wavelengths of light holds different information. So why X-rays? Most people are familiar with a broken bone and getting an X-ray. Why do we look at space with X-rays?
An X-ray, as opposed to much of the other radiation that we see with our eyes or even with our radio telescope, is really high energy radiation. So it comes from gases that are over 1 million degrees hot. And so that X-ray comes from objects that we've read about, like black holes, like pulsars, these amazing, almost lighthouse structures, very compact stars, or exploding stars. That's what X-rays are coming from.
Well, here at the Smithsonian, we're really proud of the Chandra Observatory, which was launched by the Space Shuttle. There's a model of it up behind me, and it's operated by the Smithsonian Astrophysical Observatory, the Center for Astrophysics up in Cambridge, Massachusetts. So Chandra kind of led the way and has really given us this rich view of the universe.
I have to tell you, Chandra is one of the most productive missions we've ever done. Chandra, with its view on the X-ray universe, has really transformed how we're looking at not just our own galaxy, but also the galaxies around them and their relation to black holes.
Yeah, and obviously they're looking at this high energy events, you know, like supermassive black holes, like nebulas, trying to understand how do these things form, how do they happen. One of my favorite images or areas that Chandra has studied is the Crab Nebula. And the reason that's so fascinating to me is, first of all, it's actually something that humans have been able to observe its history. So in 1054, Chinese and Japanese astronomers, basically early astronomers, saw a star explode, you know, this bright light in the sky. So here you have this extremely energetic event, an explosion of a star, and now as we observe the Crab Nebula, as you see the aftermath of this explosion, X-rays are super useful for studying that.
Exactly right, and now let's look at IXPE, at what it's going to bring. So instead of just looking at X-rays the way Chandra has, just looking at how many photons, kind of pieces of light, are coming in the X-ray regime in a given direction, it will also add the polarimetry, which is the direction in which the light, the electric field in the radiation is oscillating. So there's enormously new information that's coming from that.
Now, most of us are used to polarization, thinking about sunglasses and allowing us to see much better in bright sunlight. And that's because you have light that vibrates in multiple directions. And so a polarizing lens allows you to clear out that information and reduce the glare. But there's information in all that vibration, and that's what IXPE is going to get at, right? So all the different directions of vibration of light is telling us stuff.
Yeah, so let's give an example. At the sun, but also in some of these areas in astrophysics, we think, but we haven't seen it yet, there's magnetic fields that are going in a given direction, and electrons are going around it super, super fast, just kind of because they're bound to it, and they're emitting radiation, and it's oscillating. The radiation is oscillating right perpendicular to that magnetic field. We'll be able to detect that. So we'll see the presence of magnetic fields, for example, at the Crab Nebula, or if black holes rotate, there should be a rotational pattern in that polarization. Just amazing stuff we can gain from really observing the underlying processes.
I can't wait till IXPE launches. So when is it going to launch and from where?
It's actually ready to get launched as early as December 9th, and it's going to launch from the Cape. And guess where it's launching from? It's from the most famous launch pad in all of NASA, 39A. So it's the first time a dedicated science mission that is not the shuttle will launch from that pad.
Can't wait. And I'll tell you what else I can't wait for is another episode of EZScience.